So this is the analysis of variance in linear models assignment. So the baseline of the assignment is we have to have a system analysis using the ANOVA and the linear model suite Python with a real data sheet and to apply ANOVA and across category values. And then there are 4 tasks in P. The first one is the ANOVA, the second one is the linear model, the third is to discuss the assumptions and limitations of both, and then the last is defining them all. So what I used was 2 different types of data sets. One was country education level and income, and the World Happiness Report. So they're both from Kaggle, as you can see with up here, and so it explores the influence of income and education on with happiness. So up here, this is importing all the libraries needed. This is reading the first CSV file and the second CSV file. This is merging the 2 together and then renaming file columns. So that's here. And then dropping the columns that are not needed. So this is them combined. The first one is the ANOVA model. So I'm using the 2-way ANOVA. So for that, I use the pivot table. So the income, the education level, the high, if it's high or low, moderate, very high, or very low. So that's up here. Up here, I'm importing the other libraries that are needed, and then the formula for the values that are needed to fill in the table for all the values that are missing. And then for the 5 level of significance, alpha 0.05 with confidence, p-value is less than alpha, that the income and achievement have influence on happiness, but no influence for interactions. The second one was linear model. So for the linear model, I used the same happiness one, but for a different year. As you see here, I'm importing the libraries that are needed. This is its reading the data. So that's the data that's out on the CSV file. Right here, it's doing the box plot. So health expectancy, freedom, trust and corruption, and dystopia residue. So that's what these are. There are a few outliers in 3 and 4, so that's there. So the new data, so it shows here as that, and then everything switched down here. And the training, so the R2 score is 0.98 and then 0.97, which means the linear regression model is 98% accurate. So now to the discussion part. So some limitations in the 2-way, which is what I used, include assumptions of normality, homogeneity of variances, and independence of observations. Normality, the data within each group should be no mean distributed. The variance of the data within each group should be equal. Independence of observations within each group should be independent. And then assumptions for linear regression are linearity, independence, and homogeneity. So linearity is the relationship between the independent variable that are linear. Independence, the observations are independent of each other. And the last one, the variance of the errors, is constant across all levels of independent variables. So for the solutions, the first task, I produced an ANOVA table for all the values that were calculated, as you saw before. I can show you that here. So this table right here is the table I'm talking about. The second one was providing a box plot with outliers and putting the R2 value in order to figure out if the linear regression model is accurate or not. That part is right here, so the linear, if it's accurate or not, so it's 98% accurate. That's the R2 value. And then this is the box plot I'm talking about, which is right here. And then for task 4, by combining the ANOVA and the plots, you want to produce the outputs in the assignment. those are the solutions. The next part is Python can be used to develop useful tools in many different ways. For example, in the interval, Python provides a f1-wave function from the SciPy library, which we can use in order to conduct the one-way interval test. I use the two-way instead of a one-way. It was easier to use for this example. And then for linear regression, Python provides skin-yarn, stats models, and NumPy that will be used to implement the results for linear regression. So task 4 is a mini project that combines interval linear models. So right here I'm importing the libraries that I need as well. Here is reading the 2022 CSV file, which is the same file that I used in the first example. So this is all the data in there. The score and it's made by the per capital, so the happiness score by the capitals. Happiness score and the capitals, happiness score and per capital. So Finland's, Denmark, so the happiness score there, and it's made by that. This is repeating again. Right here, I'm providing a plot to see all the values. Then here it's a histogram. And then right here, it's also a histogram. And then down here, it's also a histogram. And then here it's a histogram. And now right here. And then now the means for the happiness score is 5.5. The GPD per capita 1410. The variance 1.18. And the variance is 1777.98. So the counting a 95% confidence interval per population mean. So that's here, the t-value, the confidence level for using normal distribution, and the confidence value normal distribution. So the confidence level for the t is 5.3 and 5.7. For the normal distribution is 5.3 and 5.7. So this is about the same, a few points off from each. 90%, 0.97 and 1.43. And the z-score for both ways is 3.73. Right here, this is a correlation plot, so it's a linear regression, in other words. So these are the data values, and that's the line of best fit for both. Box plot to show the happiness score and if there's any outliers. The Shapiro result 0.099, the p-value is 0.386. Coefficient, though, this is a way of the correlation. This XY, so 15.746, 171.27, 2798, and then this is also beta, so that's me here. So testing beta, if it's equal to 0, the null hypothesis and the alternate hypothesis. So 500.03 and then 3567.73. Then right here, R2, so the total is 150.35531. R2 1.3693, AKO 7142, and then F. Down here, this is also the linear regression, so it's a test and train in order to see. So right here, line of best fit, and then all the values that are in this. So that is the homework assignment.